Morning, everybody. Thanks for joining the call. We're going to start the webinar very shortly. Thanks for waiting. Before we actually start the webinar, I'd like to do some housekeeping and make some introductions on our side. So, firstly, Perry Krug, who's our Senior Solutions Architect based here in London and part of our European team, he's actually going to deliver the webinar this morning. In addition, what he's going to go through is the actual presentation, show you Couchbase in action, and he'll walk and talk you through different parts of our software and show you in a production environment. And then finally, of course, we'll have an interactive Q&A and we'll open the floor for any questions that you might have. So without any delay, let me now pass it over to Perry.
Thanks, Bilal, and thank everybody for coming today. As Bilal mentioned, my name is Perry Krug. I am from America, but based in London, working with our UK and European customers. So I'll just spend a brief couple moments today walking through some slides to set the stage, show a quick demo, and then I do want to spend most of the time with answering your questions. Feel free to use the questions interface through GoToWebinar, and I will most likely wait until the end to address them, but we'll be watching them as well. Okay, so with that, just a quick look at some of the customers that we've built up over the last couple of years. A number of these are based in Europe and the UK. You'll see a number of social gaming and advertising network companies, although there are a variety of other both enterprise and Web 2.0 companies on this list. We're talking today about Couchbase Server, formerly known as Membase, which came about through the merger of the company known as Membase and the company behind CouchDB. And this current version, the currently GA version, is a key value store featuring very good, very high performance with consistent low latencies, very high throughput, and the easy scalability to add or remove nodes from your cluster while maintaining replica copies and persistence to disk and all of those things that you expect from a database company. Moving forward, our next version, due out in a couple months, will also include a document storage persistence layer for performing MapReduce secondary indexes. I'm not going to spend too much time on the future features today. We will have another session, another webinar in a month's time to focus more on those. Just to set the stage a little bit, the kind of architecture and environment that we're talking about, your typical three-tier software stack has a number of users coming in from into a load balancer, either mobile devices or browsers, and then those requests are fanned out to a web and application tier. If we stop there for a moment, it's very easy to scale that layer. It's very well known and well defined that as you add more commodity hardware, you simply increase your capacity, and the system cost grows linearly because every new unit is the same cost. However, all of those requests then fan back traditionally into a relational database, which is a scale-up technology, meaning to handle more capacity, to handle more load, you're going to have to constantly add a larger and larger system, which not only increases your cost, but also makes it very disruptive to grow and increase as you have to either take down the application or perform sharding, adding a caching layer, all those sort of things that make it just very hard to really scale a relational database. And additionally, the more load and the more users you put on that relational database, the worse and worse the performance gets, until at some point you've bought the most expensive system either available or that you can afford, and your performance will continue to degrade. So where Couchbase comes into the mix is by providing a layer at the database tier that mirrors the scale-out nature of your web and application tier. It's still a single logical database to your application, but it's made up of a cluster of commodity hardware, so that not only does your performance stay constant as you grow and increase capacity, but your system cost grows linearly as you add more and more systems. So this is the kind of environment and the architecture that we're going to be focusing on today. Let's talk a little bit about how Couchbase itself works. If within a cluster of 3 nodes, you'll see that all of your active data, this is the data that your application is reading and writing to, is evenly distributed across the whole cluster. In addition, each of those documents, each of those pieces of data is replicated to another node in the cluster. You'll notice that this is not a master-slave setup where one node is handling all of the traffic and another node is just sitting idly by. Each node is actively participating in serving data and also maintaining replica copies. When your application servers come online, part of the Couchbase client library has a cluster map that defines where these pieces of data live in the cluster. And so each application server knows that in order to access a certain piece of data, it goes to that specific server that owns the data. And all of the servers are actively participating in those read and write operations. And in this way, we can maintain very, very strong and immediate consistency because you never have to wait for a write to get to some other server before you can read it. As you want to add nodes to the cluster, it's a very simple process of bringing new copies online. All of the servers are created equal, so there's no separate master or zookeeper or head nodes to manage. And then the process of actually rebalancing the data is something that happens automatically once the administrator kicks it off. And so some data, both active and replica, will be moved onto those new servers. The cluster map at the application level is updated, and any subsequent access is now performed to the new location for data. This process happens seamlessly and non-disruptively. It's an online operation without any impact to the performance or availability of data as you're growing or shrinking the cluster topology. It's also an incremental process, so that if some of it, if at any point it needs to stop or there's a failure in the middle, anything that has already succeeded will be considered valid, and anything that has not can be backed out of without any impact to the application. If we take a quick look at what happens when a failure occurs, as the servers are reading and writing to one node of the cluster, if it fails, there will be always some requests that had already been sent and will have to time out, will have to get a failure. But then once the failure is detected, the replica data that is made active, that is available elsewhere, will be made active throughout the cluster, and operations will continue. It's important to note that throughout this whole process, any server that has not failed will be able to continue serving its data without any impact. And once the failover happens, all of that data is available again. Couchbase does not automatically re-replicate the data because that would be putting an increased amount of load on an already smaller capacity server. And so we reserve that for the administrator to either add this node back into the cluster, to perhaps reboot it or add more capacity, and then rebalance again, which is what actually recreates the replicas and returns the cluster to a safe state. Okay. Spend just a couple more moments looking at some of the characteristics of Couchbase. Our performance is really derived from this very tightly managed caching layer that is built out of the Memcached process or Memcached project that our engineers created about 7 or 8 years ago and have since extended to help support Couchbase. We recently did a benchmark with Cisco and SolarFlare, which is a 10 gigabit network provider. And the goal was really to show the very lowest latency possible with Couchbase. And you'll see the purple line across the top is a 1 gigabit network card. And all of these latencies from objects of 1K to 16K is under 500 microseconds. Going all the way to the bottom, that lower blue line is an optimized 10 gigabit network interface where you see very, very consistent latency below 100 microseconds. This is not milliseconds on this scale, but microseconds, showing really that the Couchbase software itself is able to provide extremely low latencies and that your only bottleneck really becomes the network. Another way of looking at this, looking at throughput, we took a 1, 2, 3, 4, and 5 node Couchbase cluster and put up to 1.75 million operations per second through it on that same 10 gigabit network card. And while this isn't necessarily the maximum throughput that Couchbase can provide, the point here is to show very linear scale. As you add more servers, you get more capacity and more throughput possible. Changing a little bit from performance to scale, one of the more notable applications built on top of Couchbase is the Draw Something application by OMG Pop, where it's a very simple game where users on mobile devices draw pictures and then their partner on the other side of the world tries to guess what that picture looks like. It became an extremely popular game in the span of just a few weeks, growing from a few thousand users to literally 35 million users over those 5 or 6 weeks. And what's even more interesting is that the amount of data being stored grew exponentially, and even more so than the actual user population. By the end of by the peak of the growth, Couchbase was storing 5,000 drawings per second with over 3.5 terabytes of data in the cluster. And throughout that whole process, the latency and the throughput of Couchbase, the latency stayed flat and the throughput grew linearly as the game went from 6 nodes of Couchbase to almost 100 nodes of Couchbase without any downtime, without any loss of performance or loss of availability. Okay, that's it for the slides, and now I want to just show you all Couchbase in action here. So if I jump out and pop up this screen here, log into a Couchbase server that I have running. The first thing we see, and some of you may have seen this before, is just the initial cluster overview showing how much RAM and disk is available to the cluster, a brief view of the traffic being generated, and then a summary of the servers that are in the cluster. If we dig in a little bit more and look at the management and monitoring interface, you'll see that we have a very extensive amount of statistics and metrics available for the cluster, both aggregated across the whole cluster and available down at an individual node level. And this first top section is just showing operations per second, the ins, the reads, and the writes, the number of items stored, and we can drill down to the interaction between RAM and disk, our process of writing data to disk and possibly reading from it, and also the interaction between nodes, sending their replication and rebalancing data. So what I'm going to do now is show that we have 2 nodes currently handling this workload, and I'm going to add a few more. So I'm going to grab a couple more IP addresses here. And these are all servers running in Amazon EC2. They're not very powerful nodes, basically commodity hardware. And Couchbase runs equally well on either cloud instances, VMs, or dedicated hardware. So I'm going to add, let's say, 3 nodes to this cluster. You can add or remove as many nodes as you want at one time, and it's not until you actually kick off the rebalance that data begins moving around. So now you see we have 2 nodes that are active in the cluster and 3 nodes that are pending, waiting to be added. So if I press the rebalance button, this kicks off the process of automatically migrating some of the data off of those first 2 nodes onto the other 3 and evenly distributing the data throughout the cluster. So while that's going on, we can go back and look at the application's performance. And you'll see that there really hasn't been any change in the availability of data or the performance of the application getting those requests. You'll see there's some increased activity of data transferring between the nodes, and this is us sending data from one to another. But the application is constantly online throughout this whole process. And all of these metrics, all of this capability is available through our REST API, so it can be accessed and controlled programmatically. And there's also a variety of other statistics available at an even lower level when it comes time to look really deeply into the software. So that's the extent of the demo. I'll leave this screen up for a little bit, and I want to spend the rest of this time, the next 20 minutes or so, talking about or answering your questions. So feel free to send your questions over to the interface here, and I'll be happy to answer them. I see a few coming in now. The first question is talking about, just read it here. What the maximum amount of data that Couchbase can provide, and we measure everything in terms of number of items in the cluster. We have some customers that have literally billions of items. 2 or 3 billion, I believe, is the largest I've seen, and really the only limit here is the amount of RAM and the number of nodes that you can give to the cluster. So with enough RAM, there is no limit because Couchbase is a completely shared nothing architecture and has and scales linearly as you add more nodes and more capacity. Another question coming in talking about replication within a data center. So Couchbase in our current version only has the cluster is meant to be within a LAN environment where you have low latency and high throughput links between the nodes so that we can replicate the data as quickly as possible. In an upcoming version with 2.0, we are releasing a cross-data center or cross-cluster replication feature so that you can have 2 separately managed clusters keep their data in sync. And you will be able to scale both up and down each cluster independently, and then the data will replicate between them in an eventually consistent manner, whether that be between 2 clusters in the same data center or a cluster between 2 clusters over a WAN link. And it's a fully multi-master. You can have as many clusters replicating to each other as you like. Okay. Keep the questions coming. A question about performing secondary indexes and queries with Couchbase. So with the current version, we are a key value store, and that means that you're a little limited on what types of queries you can perform, although many of our customers, many of our production applications are creating their indexes within memory, within the application, and then writing those indexes into Couchbase, which is a very performant, very consistent way of managing that. With our upcoming 2.0 product, we will be adding the ability to query JSON documents. So if you're writing your data into Couchbase in JSON, you'll be able to provide indexes and queries off of any field within there. We also support non-JSON data that goes in as binary objects, where you will actually be able to query off of the keys themselves, but not necessarily the data in. Okay, we have plenty more time, so if you have any other questions, please feel free to type them into the questions interface of GoToWebinar. Another question about the languages that Couchbase supports. So we have native client drivers for PHP, Perl, Python, Ruby, Java, .NET, C, and are working on a Node.js driver. And also we are fully compatible with the Memcached interface, which means that any application, any client library currently using the Memcached protocol can access Couchbase as if it were a Memcached server and automatically get the replication, failover, dynamic rebalancing, and persistence to disk without any changes to the application code. Another question talking about how backups are done. So Couchbase, being a database, certainly provides the ability to take a backup. The current model is to back up the on-disk files, and that can be done online without any disruption to the cluster. But keep in mind that any data constantly being changed in RAM will not necessarily be in that backup. So we talk about valid backups and being able to take a backup and have that data be guaranteed safe and available, but not necessarily consistent across the whole cluster. Just like with relational databases, in order to get a backup that is completely consistent, you would have to quiesce the whole database and stop performing writes to it until that has been drained to disk. Most of our customers can't just stop their application, and so we focus on providing backups that you can take of the system while keeping in mind that they might not be consistent across the whole cluster. Another question asking about the Couchbase interface available in English or other languages. At the moment, it is only available in English. We have a partner in Japan who is in the process of translating our documentation to Japanese, and we are certainly open to other contributors to help translate the interface and documentation. But at the moment, it is only available in English. Okay, I'll take a little pause here and see if there are any other questions coming through. Another question about those backups. If you take a snapshot from an EBS volume, will Couchbase always be able to read the backup even though the data may not include the latest writes? And yes, so in the current software we are using an embedded database called SQLite, which is a very, very widely deployed, well-tested, robust database that can really guarantee that the data will be available once it has been actually committed to disk. So if you take a snapshot of an EBS volume, that data will be available to be read from Couchbase. We also provide the ability to take backups outside of just an EBS or file system snapshot by using the SQLite backup API. And going forward with our introduction of CouchDB to replace SQLite, we will also have the same backup capabilities. Are there any notification methods in case of node failure or high node usage? So we do have notifications when nodes fail. We don't currently have notifications based on traffic level or usage. Our focus really is on providing. We will provide all of the metrics, all of the data, but we rely on some external monitoring system and alerting system that can usually do a much better job than if we were to write it ourselves. So, for example, we integrate with Nagios and Cacti and make all of this information available externally, really designed to be integrated into your own monitoring system. Most environments have a central monitoring system where you wouldn't want different alerts coming from different systems, rather have it all tied together. And so our goal is to provide that information about the system, about the database, and let a better technology handle the actual alerting around that information. So a question, traditionally within SQL, you create tables with columns and do inserts and selects and updates, and how does this work in Couchbase? And this is really one of the discussion around the difference between relational databases and NoSQL. Where instead of rows and tables, you are working with objects. And so each, as in your application, when you have a user object or a game object or a data object that you're working with, that is the unit of data that you're going to write into and read from the cluster. And so it involves a slightly different data modeling, but you're going to have much more normalization of data where all of the data about an individual object is contained within a single object, and so you read and write and query those objects, but it's not the same as dealing with tables and rows. And this has a number of advantages. There are certainly differences in how your application will work with the data, but most customers, most users find that once they understand that, it makes it much easier to work with and develop applications. More questions coming in. In just a few words, Couchbase is a document database. So it is a NoSQL document database as opposed to a graph database or a columnar. Those types of things are different types of NoSQL databases, but Couchbase is a document database. Is there an Apple Store app for the administration of Couchbase? There isn't an actual supported app from Couchbase, but I know of at least one customer that does access the administration console off of their mobile device. So really, all you need is a browser. The Couchbase UI, what we're seeing right now, is built off of a jQuery interface on top of our REST API. It's a very lightweight interface and should work as long as you can access it from a mobile device. Are there any minimal requirements to run Couchbase in production, and would micro instances work? There are some very basic minimal requirements. You need to have a little bit of RAM and some CPU and disk, but our goal is to provide software that works under a range of resources and really focused on commodity hardware. However, micro instances and small instances in Amazon have really been shown not to have enough resources, not even enough basic resources. They will work from a very basic testing perspective, but I would strongly recommend against going into production with anything less than a large instance. In terms of the RAM and the CPU and I/O resources needed to keep the software working and performing for your application. Okay, that was a good run of questions. Feel free to keep them going. Another question about replication and data being distributed around the Couchbase cluster. So if you are familiar with the concept of a shard map within a relational database world, where you basically look up the location for a piece of data and then go to the particular shard that owns it, that concept is used within Couchbase to manage the distribution of our data. So we automatically have 1,024 shards, and those are mapped to individual servers within the cluster. As we need to add or remove or fail servers, that shard map is updated, basically to say this shard is now located on this server where it used to be on this on its previous server. Couchbase takes care of copying the data there automatically before making that change, and all of the client libraries have a view of this shard map. Now, the client libraries don't need to maintain a list of all of the data within Couchbase. We use a hashing algorithm to map an individual an individual item into a particular shard, and then look up where that shard is within the cluster. And since all of the clients have a consistent view, they all direct their reads and writes to the same servers for that data. We also have a lower level mechanism to prevent any inconsistency. So if a client makes a request to a server that is not the owner of a particular piece of data, that request will be returned with an error basically saying, I am not the owner for this, you need to go somewhere else, and the client library will automatically handle finding the right server for it. This is actually a fairly expected operation during a rebalance when data is moving around and some requests are already on the wire before the data has switched from one location to another, and so the client libraries automatically handle that without you, the application developer, having to see any of the error or messages. A question about whether the application needs to be aware of all of the servers within a cluster. And the answer is no. The client library provides a single logical interface into the entire database, and the client library will handle knowing what servers are part of the cluster, which servers are handling what data, but the application simply says read this data or this data, and doesn't have to know how many servers there are, doesn't need to know if the topology is changing, and doesn't need to know if any of the servers have failed. A question about the basic units of action or protocol commands. And so if you're familiar with memcached, we support that entire protocol. So you have a set to write data, a get to read data, a delete to delete data. Then you have some atomic operations like increment and decrement, which provide atomic counters within the database, which are very useful for rate limiting, for unique UID generation. We also have append and prepend atomic operations, which will just put some data at the end of a key atomically, which provides very, very high performance and consistent access to a key without having to read and write each part of it back and forth. And then we also have some other commands that allow you to only insert data if you perform an add, or only update data if you perform a replace. And we give the application the control to manage how it wants to work with the data to provide some very complex capabilities. Asked another question asking generally about some of the high-level use cases that we see for Couchbase. So probably our most common type of customer is social games. We our biggest customer, Zynga, is the makers of Farmville and Cafe World. They have used Couchbase and are continuing to use Couchbase extensively as the persistent store for for many of their game properties. They also recently bought OMG Pop, which were the makers of Draw Something, which also used Couchbase. We have other social games like Playdom and Disney, Playtica, a variety of large and small social game, EA, PopCap, social gaming companies. So the way that social games deal with data is very similar to standard user profile and session management stores, and so that has become another very popular use case for Couchbase in large and small web applications. We also have a very strong history of providing a better Memcached interface. So any company, any organization, any application that's already using Memcached can put Couchbase in there to provide a much more robust, supported, monitored interface that's just as fast as Memcached, but also is replicated, persistent, and can be dynamically grown or shrunken, whereas Memcached cannot. We also have a long history with the online advertising and network agencies, which need to provide very, very low latency and high throughput access to their interactive applications, which support a large number of reads and a large number of writes. AOL advertising does some couple billion impressions a day, all off of Couchbase. Question, if NoSQL is document-oriented, is it a good choice to build financial applications with NoSQL, or would an R DBMS be a better choice? Talking about examples of customers and orders and invoices, and if you make documents from those entities, can those objects later be joined to produce reports and so on? Yes, all of that can be done with NoSQL, but I would also say that not every application that uses a relational database needs to be replaced with NoSQL. You really want to choose the right tool for the right job, and if you're trying to address performance and scale and flexibility of schema, then NoSQL is certainly the best choice. The way of handling financial transactions and object relationships is certainly different, but all of the same capabilities can be performed. The difference really, one of the differences between relational databases and NoSQL is rather than the database enforcing the relationships between objects and the schema of those objects, it's now up to the application and the developer to manage those connections and relationships. And it provides for much more flexibility within the code in order to do that, but also requires a little more intelligence and a little bit more processing by the application in order to handle that. So all of those capabilities and all of those applications are certainly capable of being done by NoSQL, but if you're not in a high scale or a flexible environment, you don't necessarily need to just use NoSQL to replace all relational databases. Is there a way to get all keys within Couchbase? There is. There's a way through the current software to ask for a list of the keys. You can also pull out the database files underneath and query them directly. And with our upcoming 2.0 product, you will be able to provide range queries and aggregate queries on both the keys and the fields within the documents. Okay, great. We're at about 45 minutes. I'm happy to continue taking questions. Feel free to keep sending them over. If you're looking to drop off, I thank you very much for joining. Keep your eyes open if you'd like to join again. We'll be having another one of these in a month's time or so. Hopefully we'll be able to talk a little bit more about our upcoming 2.0 product and the features like cross data center replication, MapReduce, and a new UI that we're putting on top of it. I'll give you all just a couple minutes more if you have any other questions. I'm happy to stay here and keep talking. A question about performance benchmarks. We just started releasing some of our benchmarks. If you go to blogs.couchbase.com, you will find the same information that I presented with our Cisco benchmark, and we're also working on some other benchmarks comparing to other NoSQL. Couchbase really and truly can guarantee sub-millisecond up to 2-second response times for any reads and writes that are coming out of RAM. This happens because of our Memcached interface, and it's important to note that while raw speed is certainly important, the ability to guarantee the consistency of that latency is even more important to applications that run 24/7 under a variety of load. Many of our customers have very high peak loads and not so high low loads where they need to be able to provide the same user experience, the same snappy interaction, and that really all comes from the consistent interaction with the database. We have seen and heard from other users of other NoSQL databases that as you increase the load or as you make changes to the topology, the performance really suffers. And most of these other NoSQL vendors, MongoDB and Cassandra and React, really start out at 5 to 10 milliseconds for a basic response, and then it just goes up and up to 20 and 30 and 40 milliseconds without the application being able to understand why it's being slow. But Couchbase really stays below 2 milliseconds, and as I showed, with the right network and the right network hardware, you can get even below 100 microseconds for hundreds of thousands of requests per second. And I have seen customers and tests and production workloads really performing at those levels. So Couchbase really has a reputation for very good, consistent performance, low latency, and very high throughput, and I think it bears out in all environments. Question: are there tools like PHP, MySQL Admin, or SQL Management Studio? There really aren't at the moment. That sort of interaction and layers on top will develop as the NoSQL and Couchbase industry evolves over the coming years. But you also don't really need the same kind of tools that you do with MySQL and other relational databases. Couchbase in our 2.0 version has a management interface where you can develop queries and create your views, but you also don't have to perform the same kind of query optimization and schema management that you do with a relational database. So I would encourage you to go to couchbase.com and get to the develop section where there are tutorials and client libraries and examples on how to develop applications with Couchbase. So let me just put this here. Yeah. All that you need can be found from Couchbase.com. Comparing another question, comparing the size of the Couchbase user base with other databases. In all honesty, Couchbase doesn't have the largest user following at the moment. That's something that we are working on building up. Certainly, if you want to compare to MongoDB, they have a much larger community. However, Couchbase has currently the largest number of production nodes in production. We have well over 3,000 instances of the software currently running in production that we know about. And there are probably hundreds to thousands more that are just working off of our open source software. And while certain other databases, especially MongoDB, are very easy to get started with and prototype applications on, they really have a hard time being run in production at any sort of large scale. We've been speaking to a number of customers that really tried to get Mongo and Cassandra to perform at large scale, and for whatever software or performance reasons were unable to. Whereas Couchbase typically has clusters well over 20, 30, 40 nodes, as well as smaller clusters, 3, 4, and 5, where there's no difference in performance, no difference in the architecture, no difference in the administration when you go from one node to 10 nodes to 30 nodes. Thank you, Bert. I think I'll have to quote that, not a question, but a quote saying, "It's so simple, it's scary." Couchbase really focuses on being simple as our first tenet. The fast comes from our memcached layer. The elasticity comes from our ability to just easily add and remove nodes without any disruption to the application. But all of this starts as being simple. We have one package that you download. Every node is created equal. All of the UI is available from any of the nodes. You don't have a separate management layer. You don't have a separate caching layer to manage. You don't have a separate persistence layer. Everything is built into the one system, and it's really very easy to get up and running. And then especially when you're running in production, operating and managing the software, identifying trends, any possible problems, the sizing of the cluster, we make all of those metrics available. Okay, just about 10 minutes more. I will stay on the line if there are any final questions. And again, I thank you all for joining this webinar. I hope I was able to answer all of your questions. And again, we'll be doing this hopefully on a fairly regular basis, trying to have different and new content, so feel free to come back. One more question coming in. Are there locking mechanisms? There are ways of performing locks and semaphores within Couchbase. However, as a best practice and as our design of applications, we try to avoid that as much as possible, really because you have your performance will suffer greatly if you are locking data. We take the approach of what's called opportunistic locking, where it's up to each application server to know that a piece of data has changed, and we have the operations to manage that, so that you're never waiting for something else to happen. You're simply moving on and either performing an operation or not performing it, rather than locking and blocking from the application. So there are ways of managing concurrent access. Certainly we are atomic on a per item basis. We are not transactional, but you can have concurrent and consistent updates to the same data from any number of threads without having to worry about corruption or overwriting of the data. I hope I'm not scaring you too much, Frankie. It's certainly a different world coming from relational databases to NoSQL. If you'd like to email me or get in touch with us, I'm happy to dig into your particular application or questions a little more deeply. There is some documentation and reading resources online that can help describe the differences and how you build an application with NoSQL versus what you're more familiar with in the SQL world. Are there questions that you can recommend to do your own benchmark? Sorry, are there test drivers to recommend that I could do your own benchmark? There are a couple different load generators that work with both Memcached and Couchbase. Some of them we have on our website. Some of them come installed with the software. We've also been using the YCSB, the Yahoo Scale Cloud Benchmark. I forget what that stands for. YCSB. I'll tell you in a second. Yeah, the Yahoo Cloud Serving Benchmark is an application framework that can work across multiple different databases. And so we've been using that in our own benchmarking that we will release shortly. Usually it makes the most sense to have your own application, either a test or actual application that as closely mirrors your own workload as possible. And I'll make the claim here that if you have any application that is not faster on Couchbase, I would like to know about it and work with you because all of our customers today see very, very low latency, high performance, much better than they have seen with any other database system. Bert, I'm surprised you're the first one to ask this question at 5 minutes before the end, but 2.0 will be available towards the middle to end of October as a general release. It is currently in a pre-beta release. You can download it and get your hands on it to play around. We plan to have a beta in early September. We are currently running a beta program for that, and we'll then work towards the GA release in October. I'm told that I should say beta instead of beta. That's my American accent coming through. Okay, I think I'm going to wind this down. I thank you all very much for your attention, and please feel free to download Couchbase and get in touch with us if you have any questions. We have an online forums. We also have a full support team if you're interested in talking about a commercial license to the software. Thank you very much, and I wish everybody a lovely day. Take care.